Hi, hello everyone, especially my brothers in profession. Before going on, I would like to share the topic for this afternoon regarding the required draft to arrive even kill at destination. So this competition is very important for those newly passed chief officer. They can encounter this kind of competition when they are on board a bulk carrier vessel. So before anything else, let me share my seafaring life. Actually, I started my career as a seafarer way back 1980. I was on board a coastwise vessel, general cargo vessel. On board, my first vessel was Lorcon 4. I was connected in Lorenzo Shipping Corporation, flying only between Davao, Manila, Cagayan, and Manila. So these are always my regular route when I was an apprenticeship. So I was there for 1 year. Then after my shipboard training, I took my examination. At the age of 22, I passed the board examination for third mate. Then eventually, I took the command at the age of 22 on board a Far East vessel, which is also belongs to Lorenzo Shipping Corporation. I was a third mate there for 1 year. Then after serving 1 year as a third mate in 1984, I took the examination for second mate. So I was second mate at the age of 24. And then at the age of 27, I was second mate in ocean-going vessel. So from there, I spent 10 years as a second mate. Then after that, I took examination for chief officer. So at that time, it was the time where the computer examination have just started. So I was sponsored by my company. If I can pass the board examination for chief officer, they will be the one to pay my tuition fee for my review. So since I was able to hurdle the examination as a chief mate, so I was free of charge because they're the one who settled my tuition fee for the review in exchange of passing the board examination. So that was very long time ago when I served as chief officer. And I used to board a vessel most of the time, bulk carrier vessel, ranging from handy size, Panamax size, Kamsarmax size, and Cape size is the largest one for the bulk carrier. And then after 3 years of my term as a chief mate, I took also examination for master last year 1999. So I was able to hurdle the examination, and I was master at the age of 39. That was too late already because I spent 10 years of my second mate. I really enjoy being a second officer, being a navigation officer. I already circumnavigate the whole world. So from east to west, north to south. So that was my route before with a tramping vessel. So I took my command actually 2001. My first command was a handy size vessel. From there, I have different sizes of vessel, which is bulk carrier, and I serve as master for I think 12 years now. So a total of for almost 40 years as a seafarer. Could you imagine how long my service as a seaman? So during my vacation time, I could only spare or spend my time with my family 2 months, 3 months, sometimes 1 month, or even 1 week if there is an emergency, a call from the company. So I had also experienced that when I went home after 1 week, then the company called me up because that was emergency. I joined the vessel, but I promised to them that after 3 months I should be repatriated, because imagine after 1 year you serve on board and then in 1 week time you will be deployed again. So that is very terrible, and you have no time for your family. So it was really happened to me during my second meet. So I joined the vessel in India, and then we proceeded to Iraq, where we loaded cement in bags. So that is by bags. So it took almost more than 1 month before it was fully loaded, because the loading is not bulk, that is in bags. So it takes time to complete the loading. So after that, the vessel proceeded to Singapore first for bunkering before it will be discharged to Saigon, Vietnam, because the destination of the cargo was intended for Vietnam. So I decided to request to the master that I should be repatriated in Singapore, because that was the agreement that once the vessel's in Singapore, I have to take my vacation. I have to go back home because I have only 1 week with my family after a long 1 year on board the containerized vessel as a second mate. So they also allowed me to go home at that time, although the company found very difficult to find my reliever, but at least I was so blessed because they were able to find my replacement. So I disembarked in Singapore. I stayed 1 night in the hotel before I was repatriated back to Manila. So that was a very happiest moment then, because I was able to see my family back then. So that's all for my sharing, being a seafarer. Until now, since this is pandemic time, and of course I have nothing to do here. I used to be always at home because we have restriction to go outside because of the COVID-19. So I always spend my time here at home. So I decided to make this video for me to be able to share my experience. So my topic for this afternoon is regarding the calculation of draft required to arrive even keel at destination. Because sometimes the charterer requested you to calculate if there is a restriction at the discharging port, there is a draft limitation. So I have the format being used for the computation. So let's have this format. Actually, this format is being used when the vessel is transiting Panama Canal, because in Panama Canal you are only allowed, I think, if I'm not mistaken, at least 12.04 meters only. That is the required draft even keel with a density basis on density of 0.9954 and your draft should be 1204. So in this example, I just calculate for the Panamax size vessel the restriction. This is not actually in Panama Canal, but this format can be also used for computation purposes. So in this example, Uh, I have here density at destination, which is 1.0240. So this is not standard. This is the specific gravity or density at the discharging port. So the draft restriction at the discharging port is 13.58 meters. So what you have to do is to find the displacement for the corresponding draft 1358. So it is found out that displacement against this draft, this mean draft, is 87,902 metric tons. So this is the data. So this is the draft along this column. This is the draft. I only pick up those important data. And this is the displacement. This is the mid-B or the center of buoyancy, and the center of flotation, which is F, and MTC, moment to chin stream, in 1 centimeter, the TKM and the TPC, that is tons per centimeter. So these are the data to be used in my calculation. So you have to find out also the corresponding LCB on this 1358 draft, which is negative 3.67, and also the LCG as same as number 3, since LCG must be equal to LCB. So you have to affix the same figure, negative 367. Now in this number 5, item number 5, the saltwater displacement. So you have to convert this to saltwater displacement from 1024. This is 1358. So you have to correct this one by using this formula. So displacement times multiplied by 1024, since this is the specific gravity at destination, always divided by constant 1025. So the result is 87,816.24. So there is a difference already. This is already the corrected displacement with respect to the density of 1025. And the LCG, so you have to use the LCG here in number 4, which is negative 367. So to obtain the longitudinal moment, you have to multiply this column, width column, and the LCG column. The LCG means that this is the longitudinal center of gravity. This is LCG. So if you multiply this figure, the result is longitudinal moment. Okay. So this is for the weight. So now your intention is to consume fuel and fuel tank number 6, that is port and starboard. So the LCG is 44.41. That means this is the distance is half of a midship. This is 44.41 from the midship. And likewise the freshwater, this is 100 metric tons the production. This is also up from the midship, so 98.48. So this is the longitudinal moment. So by algebraic sum, this is the total moment. So gentlemen, I would like to remind you that consumption, it always bears the positive sign, while production bears also negative sign. That's why here in freshwater, since this is production, the 100 metric tons bears negative sign, and for the consumption, as is. So now if you sum up by algebraic sum, this is the total weight or total displacement. Okay. So you have to compute again if there is any correction for the displacement. Since the loading port density is 1025, so no need to apply correction. So just leave as it is. So this is 88,210.24. So the mean draft at this present displacement, we will find it out here. So this is the displacement, 88,250, and this is the corresponding buoyancy, center of rotation, the MTC. Okay, so that is the data. And then this is a maximum mean draft at the loading berth, which will result in draft 1. So if this is your departure draft, this is maximum draft on departure, because this is your mean draft. This is the midship draft. The maximum draft is 13.68 actually, because of the trim. Okay, so if you achieve this draft, you will arrive at 13.58. So you will achieve the restriction at discharging port. Now the vessel is sag. The mean midship draft must not exceed this value. If the vessel is hag, the mean of the fore and aft draft must not exceed this value. Any safety margin should be deducted from this value. So in number 10, item number 10, LCG at loading berth, same as number 7. So this is the LCG, because if you divide the total moment with this total displacement, this will give you negative 3.517. So you have to affix it here. Okay, then find the data of the LCB, which 1363 from here. Yeah, that's it. That is the center of buoyancy. So you have to affix also there. Then you get the difference, negative 3.517 minus negative 36.65. Then this will give you the trimming lever distance, 0.1335. Then trimming moment lever, you have to multiply displacement, no, 88210 this one, the lever. So this will give you trimming moment lever. This is the trimming moment. Then after that, the MTC from hydrostatic data and corresponding 9, you have to find out the MTC. So this is the MTC, no? Then on item 15, trim on completion of loading, that is trimming moment number 13 divided by MTC. So you have to divide this one. Then the result is the trim on completion of loading, trimming moment, divided by MTC. So this is your required trim on departure, so that when you consume and produce also water at this designated tank, then it resulted you to arrive even keel at destination basis on 1024 density. Okay, so by computation purposes, since you are using your midship is 13.63, normally if you have the knowledge for your trim, because in trim you have to divide it by 2 for a simple calculation. So what is the half of 10.1, or let us say 10 centimeters? That is 0.05 meters. So for 0.5 meters, this should be added to 13.63 in order for you to be able to get the draft up, which is 13.68. Now for 13.63, if you subtract it by 0.05, since you have your trim 0.10 by the astern, naturally, you have to subtract it in order for you to obtain the draft forward, which is now 13.58. So if you subtract this 13.68 minus 13.58, then this will give you 0.10 meters trimmed by the stern, or 10 centimeters trimmed by the stern. So gentlemen, I think this is only what I can give to you the calculation for the estimated drop on departure to arrive even keel at destination. I hope what I have discussed this afternoon would enlighten and inculcate to your mind, and for sure this would be of great help when you are on board a bulkier vessel, especially when you are very novice to your profession as a newly passed chief officer. Thank you for listening and have a nice day, gentlemen. That's all for now. Bye bye.